Hello, my super cool, awesome, amazing students. How are you doing today? I hope it's well. If not, send me an email, let me know. We can try to work everything out. But today we're going to start on the second section in the 4 parts of our first exam, right? So we have chapter 1, which goes over a lot of the definitions and the cool background into the economic way of thinking. Today we're going into chapter 2, which is production possibility frontiers. We're going to live in this abstract world for, an hour or so where we only have 2 goods that we're producing, and we're looking at how much can we produce of each good to be considered efficient, and what are the trade-offs that we have in between the two. So I actually find this chapter a lot of fun, so I hope you enjoy it, but let's go ahead and get working. Let me set this up. All right, perfect. Let's get down to business. So chapter 2 kind of introduces the economic problem. It's sort of the beginning of what we got to think about with these different trade-offs that we're making, or how we're going to make these certain arrangements, right? So like every chapter, I have a few chapter goals for you. These are the things that if you're wanting to study for the exam, or you're wanting to kind of figure out what you need to focus on, this is a great place to start. So the chapter goals, I always build around what will actually do you good in the real world after this class, right? Because having micro knowledge is cool, but knowing how to apply micro knowledge is even cooler. So some things that might do really well for you is knowing what the production possibility frontier is and how to kind of calculate opportunity cost. Because once you know how to calculate opportunity cost or talk about opportunity cost, that makes it so that you can explore a whole range of conversations when you're looking at trade-offs, especially when it comes to policy. The next goal would be to understand and explain the difference between marginal benefit and marginal cost, and what these sort of things mean and how your preferences play into it. Then you need to describe how specialization and trade make resource use more efficient, and then explain how current production choices expand future production possibilities. For example, current production choices. I can either produce pizzas or pizza machines. Well, in my house, I can only produce so many pizzas, right? I have a very small oven, so maybe like, I don't know, 10 pizzas a day. If I instead decided to produce pizza machines, and I had like 3 or 4 of those, well, then in the future, I could produce a lot more pizza, right? So looking at those sorts of trade-offs is a very fundamental part of economics, because we have to think about this in the long and short term. So let's start with our first cool tool. So we have lots of really interesting tools that we're going to use in this. The first is going to be the production possibility frontier. So when I give you a PPF, that's the way I'm going to call it, the production possibility frontier is the PPF. I'm going to give it to you in either one of 2 ways. The first is going to be a graph. So we're going to look at the graphical parts of this. The second way is going to be in a table. Now, your homework does include a table, and it will kind of show you the other side of what we were exploring in the classroom setting today. So essentially what the production possibility frontier is it combines 2 goods. So let's say, what do I feel like making today? Dun, dun, dun. Let's see, we got nail polish and pins, right? So we can produce nail polish and pins. We have all the resources and the capabilities to do this, but I only have so many workers, right? There's only so many workers. So I can either have those workers working on pins, or I can have them working on nail polish, or maybe I can have them working on both. We got to figure out what this trade-off is. If I want to produce 100 more nail polishes, well, how many pins am I going to have to give up making instead to make this sort of nail polish, right? So looking at that trade-off is going to be really important. These PPFs compare the relationship of these goods, ceteris paribus. Now, ceteris paribus is just a fancy word that economists use that say all other things equal. So we're assuming that I'm producing only pins and nail polish, and the number of workers stay the same, ceteris paribus. The number of supplies that we have stays the same, ceteris paribus. The weather and the political environment and everything else that could possibly affect the production of these 2 goods, we're going to assume stays the same. Now you're saying, wow, we're making a lot of assumptions. What's up with that? The purpose of this is because we need to understand the very basic parts in economics. So eventually we're going to get to the point where we can figure out that there's different types of people and different types of products. It's not always 2 goods. There's not always 2 goods. There's normally way more than that, right? But once we know how to work this out for 2 goods in a very understandable environment, then we can make the environment too complicated. Then we can add more goods into it. Then we can start to expand these models and make them a little bit more intuitive. So it's neat. It's so neat. So let's talk about two goods. So I'm going to need two goods to discuss, and I'm a very hungry person all the time, and I love pizza. So we're going to talk about pizza. The first is going to be Emo's Pizza. You know, that St. Louis style pizza. I moved here about a year ago, and everybody was like, ugh, don't try the St. Louis style pizza. It has that Provel cheese. What are you talking about? I tried it. It's amazing. If you haven't been to Emo's yet, try one of their pizzas with Provel cheese. It seems like either people love it or hate it. There's no just like, but it is so good. So try the pizza. So we're going to talk about pizza, and we're going to talk about soda. So I'm from Atlanta, so I'm going to use Coca-Cola because it's the home of Coca-Cola, and it is branded on everything. So we're going to compare these two. All right. So what does a production possibility frontier look like? Let me break down this essential parts. We see on the left that we have a table with 6 distinct different possibilities, so 6 different sets of goods that we could be producing. And on the right, we have kind of a graph that shows this, right? So let's look at possibility A. Well, in possibility A, I've decided to only produce sodas. So I've put all my workers on the soda line. There's none over in the pizza factory. They're just, no one's over there. We're putting everybody on the soda line. We're using all of our resources, all of our goods, everything only for sodas. Well, in that case, if I'm not spending any resources at all on pizza, I can make 15 million cans of soda. Okay, let's go to the other extreme. Let's go to possibility F. Let's say instead, I want to produce only pizza. I don't care about soda at all. Actually, that's kind of true. I've never had a soda, which is really weird considering I'm from Atlanta, which is the home of sodas. But I've never actually had a soda. I grew up in a very weird family. Anyways, so let's say that I only produce pizza. I put all my workers on the pizza line. They're all working there. The soda factory, they're just sitting over there. But the pizza factory, it's pumping and everything's going on, right? Well, if I put all of my resources only into pizza, I can produce 5 million pizzas. Wow, a world with 15 million sodas and nothing to eat is a miserable world. A world with 5 million pizzas and nothing to drink is a miserable world. None of those two extremes really sound like where we want to live, right? Instead, we might want some sort of possibility that's in between the two, where we have some soda and we have some pizza. Now, you'll notice that this curve bows outwards, right? It's not a straight line in between 15 million cola and 5 million pizza. Instead, it's kind of a bowed line. The reason for this is because, let's say that, for example, I'm starting from 5 million pizzas, and I really want sodas. So I'm going to give up 1 million pizzas. So I'm only going to produce 4 million pizzas. And that means all the extra workers I have, all the extra supplies that I have, because I'm only making 4 million pizzas now, they're going to go over to the soda line. Well, they're going to be really productive at first, right? Because going from 0 sodas to, in this case, 5 million sodas, that's really productive. That's doing good. Well, this initial productivity is more than just a linear combination of the pizzas and colas. Instead, if I don't have everybody scrunched up on one pizza line, I instead have some people on the pizza line and some people on the soda line. They have room to breathe. They have supplies. They're going to be slightly more efficient. The slight increase in efficiency is why we see that this curves outwards. Isn't that kind of cool? I think that's kind of cool. That's pretty cool. So we have possibility A, B, C, D, E, and F. B, C, D, and E is just having progressively more and more pizza and less soda in those situations. Here's just a bigger version. I probably should have gone to the bigger version. I forgot that was there. So let's split this up into 2 different regions. Because something that I tend to ask a lot in this course, what did I do? Go back. I was trying to rearrange things. One thing that I will always ask you on your test, and I always ask you on your homework, is something attainable or unattainable? Okay. We know that I can make, if I put everything into sodas, 15 million sodas. And if I put everything into pizza, I can make 5 million pizzas. But let's say the bundle of goods that I want to produce is 16 million colas and 6 million pizzas. So like way out here, I'm going to produce those. I can't do that. I don't have the workers for that. I don't have the dough for that. I don't have the metal for that. these bundles of goods are considered unattainable because they're beyond our production possibility frontier. They're way out here in, I was going to say left field, but it's actually in right field. They're way out here in right field because these are bundles of goods that we can't produce. We just don't have the stuff to do it, so they're considered unattainable. Now, the ones that are inside the curve, these are attainable. We can definitely make these. If I have all these supplies, I can make 1 pizza and 1 soda. Now, is that efficient? No, because I have 2 giant factories and lots of workers. Making only 1 pizza and 1 soda doesn't make sense, but I can do it. If I can manage to do it, or I can manage to make that amount, it's considered attainable. So this is the attainable zone. For example, I have Z right here. Z is located at 3 million pizzas and 5 million colas. I can absolutely make that. I can technically make more though, right? Because if I'm making 5 million colas, well, 3 million pizzas, that's not using all of my resources. If I use all of my resources, I can continue out to point E right here where I'm making 4 million pizzas with that 5 million sodas. Your goal to be efficient is to get on this blue line. This blue line is called the production possibility frontier. It's the line that runs in between A, B, C, D, E, and F. This right here, this is efficient. So sometimes, especially on your homework and test, I might give you a point. I might say 5 million sodas and 3 million pizzas, and you'll say, ah, that's right here. Well, this is clearly attainable. So it's attainable. Click that box. And then I'm going to say, okay, well, is it efficient? Well, it's not on that line. It is not on this line right here. It is not on one of these combinations that we see for the possibilities in our table. Therefore, it is not efficient. It is not, and what does it mean to be efficient? Efficient means that we are utilizing all of our resources. All of my workers are employed and they're working their hardest. All of my resources are being used and they are working their hardest. To be efficient means I'm using everything. I'm not leaving a machine just sitting doing nothing. I'm not leaving a worker just unemployed, not doing anything. Instead, we're at that combination and we're pushing the boundaries of efficiency, which is just kind of cool. So what does it mean? What is the big idea of production efficiency? Well, any point inside that frontier, like I said, is attainable. We can technically make it. Now, is it the smart move? Not always, but we can do it. Points outside the PPF, the things that we cannot produce that are well beyond what our production possibility frontier are, those are unattainable. We achieve efficiency if we cannot produce more of one good without producing less of the other, right? So let's see this point E right here. Let's say that I wanted to produce more colas and I'm at 4 million pizzas and 5 million sodas. Well, that's right on the line of my efficiency. It's not like Z where I can just add more pizzas or add more sodas. Instead, if I want to add more sodas, well, if I just add more sodas, I'm out here in the unobtainable zone. I don't want to be in the unobtainable zone because I can't attain that. Instead, I'm going to have to reduce all the way over to D the amount of pizzas that I have. So if I want to go to about 8 million sodas, I have to come down to 3 million pizzas. Or I guess what is D? 9 million sodas and 3 million pizzas. I'm going to have to give up some pizza to make more sodas. When you have to start giving up something to make more of the other thing, this means that we're production efficient. We are doing our jobs correctly, and that's good. So that means that there's trade-offs, right? Because obviously, what did I have to do in that situation? Well, if I wanted to move from 4 million pizzas and 5 million sodas to 9 million sodas, I had to give up some of those pizzas to get some sodas. That means I'm trading off between these goods. Every choice along the production possibility frontier, moving from B to C, or C to D, or D to A, means that we're giving up some sort of trade-off. We're having to give up some sodas to make pizzas, or we're going to have to give up some pizzas to make sodas. And we call this an opportunity cost. So as we move along this production possibility frontier, we're going up and down along it. We produce more pizzas, but if we produce more and more pizzas, we have to give up sodas. The amount of sodas that we're giving up increases, right? So if I'm moving from A to B, I'm making 1 million pizzas. At first, I'm only giving up a little bit of soda. Then eventually, when I'm going from E to F, I'm getting in that last million pizzas. To get that last million pizzas, I have to close down the soda factory. we're starting to give up a lot of sodas then, right? So the opportunity cost of that additional 1 million pizzas can be 5 million sodas. That gives us a way to measure it. We're not even measuring this in money. We don't have to talk about money. Our opportunity cost can be, what's the next best thing? What am I giving up as the next best thing? If I'm making more pizzas, there's an opportunity cost for making those pizzas of sodas that I'm going to have to not make, right? Isn't that cool? All right, I'm kind of nerdy, right? And I'm just thinking this is like so cool. I remember years and years and years ago taking my first econ class. Actually, I hated my first econ class. That's a bad example. Let's say my second econ class. I just saw this and it all clicked and it made sense. And I'm like, this is how the world works. This makes sense. And it's just like, it was an eye-opening experience and I was so happy. So let's talk about opportunity cost, because I will ask you to calculate this roughly with very rough numbers on your homework and on your test. So let's use the example I was talking about, moving from E to F. So moving from the point where we have 4 million pizzas and 5 million sodas to having just 5 million pizzas and 0 sodas. Well, what's the difference in between these 2 points? We increase our number of pizzas by 1 million. Okay, all right, cool. We have a 1 million increase in pizzas. Now, what happens to sodas? Well, we see that we go from 5 million sodas to 0 sodas. So we're decreasing by 5 million sodas. So what's the opportunity cost of having this fifth 1 million pizza? So we have our first 1 million, our second 1 million, our third 1 million, our fourth 1 million, this fifth 1 million of pizza, going from 4 million to 5 million pizzas. Well, that 1 million increase means that we're decreasing soda by 5 million. Okay, all right, all right, cool. So if we have 1 million pizzas, but we're giving up 5 million sodas, this means for each additional pizza, we're giving up 5 sodas. The opportunity cost of having 1 more pizza is the 5 sodas that we have to give up. Boom, done. That's your opportunity cost. Now, let's say we're going the other direction, okay? So we're starting at F. We have 5 million pizzas and 0 sodas. But what we want, because we're real thirsty. They put a little bit too much salt on that crust. We're kind of thirsty right now. We do not want to live with only 5 million pizzas. We would really like a nice, refreshing soda at this point, right? Well, let's say that we want to move from this 5 million only pizza world to instead a 4 million pizza world that has 5 million sodas in it. Okay. Well, moving from F to E, what do we see happen? Well, we're increasing the number of sodas. We increase from 0 sodas to 5 million sodas. So we see an increase of 5 million sodas. Then for our pizzas, we see that we have to go from 5 million pizzas to 4 million pizzas. So we have a decrease of 1 million pizzas. Okay, so we increase 5 sodas for every 1 pizza. So what does that look like in opportunity cost? Well, to have 1 more soda means that we're giving up 1/5 of a pizza, right? Because it takes 5 sodas to make 1 pizza, then 1 soda is 1/5 of a pizza. So the opportunity cost of having 1 more can of soda at this point is 1/5 of a pizza that you have to give up for it. Now, opportunity cost can go both directions like that. I'll always be very clear on what direction I'm asking about. So what you've probably noticed, if you're paying attention, is that the opportunity cost isn't always the same at every single point along this graph. And that's because resources are not equally productive in all activities. If I have a pizza oven, okay, like technically I can use that on a soda line, but I'm gonna have to like tear it apart for parts and rebuild it, and it's not gonna be very efficient. So if I use it in a pizza, place, it's gonna be really efficient. That's gonna be a really, really good pizza oven. But if I take it to the soda line, maybe not as efficient. I'm gonna maybe get some usable parts. Let's use a worker. Let's say that we have someone who's been working down at Emos for the past 20 years, right? If I put them in a pizza factory, they're gonna do great. They're gonna be a very efficient laborer. They're gonna get things done and it's gonna be awesome. Now, can I take that same worker from that pizza factory and put them into the soda factory? Sure. Totally could. Are they going to be as good at making sodas as they are at making pizzas like they have for the past 20 years? No. So not all resources are equally as productive in all the different activities. And that's why it bows outwards. Because sometimes For example, here we might have all the correct pizza workers at the correct pizza line, and here we might also have all the soda machines over at the soda machine line. Right here we might be more efficient because we're not trying to force different factors of production to act in a way that they're not good at, right? Right here, I'm not asking the guy who's making pizzas for 20 years to go work on the soda line, right? So this outward bowing production possibility frontier, the fact that this line bows outwards means that the quantity produced of each good increases. As it increases, as I produce more and more pizza, the opportunity cost is going to go up. Notice right here, if I'm only making like 1 million pizzas, I don't have to give up very much sodas, right? Because I'm taking all the people who are better at making pizza, I'm telling them, okay, all right, leave the soda line, go over to the pizza factory. And they're doing great. So I'm not giving up a lot of sodas, and I'm getting a lot of pizzas. Now, eventually, I'll get down here to the point where I'm moving in between that last million pizzas. Okay, I have 4 million pizzas, and I need to make more. What am I going to do? Well, I'm going to go over to the soda factory. I'm going to take those last couple workers, the ones that have been making sodas their entire life, and tell them that they're making pizzas now. I'm going to take those machines that have been making sodas for forever. I'm going to repurpose them, and they're going to be pretty inefficient pizza machines now. So I'm going to take them over there. Well, I'm going to have to give up a lot of sodas to gain only a little bit of pizza, because these aren't necessarily the people or machines specialized in pizza, right? So how do I use my resources efficiently? Well, to be efficient, we want to be on that production possibility frontier line. We want to be to the point where we cannot produce anything else without giving up something. Technically, all points along the PPF are efficient. Now, does that make them smart? Having 5 million pizzas technically can use all of my resources, and I'm using all of my resources, that's sufficient. But that means that we have no soda and nothing to drink in the world. Maybe that's not the best idea. So to determine which of these alternative efficient quantities to produce, we have to compare the cost and benefits. In a world with 15 million sodas and absolutely no pizzas whatsoever, there's some cost and benefits there, right? Like, it's cool, like we get the benefit of all the soda, but there's the cost of, like, we have no food. So we're going to compare these to figure out where exactly we want to be. How do we compare these? Well, we do these through the ideas of marginal cost and marginal benefit. Marginal cost is how much do I have to give up for one more of something? It's kind of the opportunity cost, right? And the marginal benefit is how much benefit am I going to get from one more of something? If I'm in a lost desert of 5 million pizzas about anything to drink around, there's going to be a benefit for that first can of soda. And it's going to be a pretty high benefit because, like, I'm dehydrated in pizza land. But once we get to 5 million sodas, does the 5 millionth soda really matter to me as much as the first soda did? Maybe not, right? So the production possibility frontier is going to determine our opportunity cost. It's what we have to trade off to move along that curve, right? The marginal cost of a good or service is the opportunity cost of producing one more. So I've been saying this on and off, but let's look at what this opportunity cost actually is. So if we're literally swimming in soda world of 15 million, and we want just something to eat. So we tell the people who are good at making pizza to go back to the pizza line. Well, then we're reducing the amount of sodas to 14 million because they weren't really good at making sodas anyways, but we get a lot more pizza. We're getting 1 million pizzas because the pizza people are back at the pizza ovens, right? So this opportunity cost is very little. We're not giving up a lot of sodas to make that first 1 million pizzas. That second million though? Okay. Well, maybe I'm taking the people who are kind of okay at making pizza, but also kind of okay at making soda and telling them to go over to the pizza line. Well, then I'm going to lose a lot more soda than I did before, and I'm not really getting a ton of pizza because they were good at both, right? So this cost becomes a little bit more, and it becomes a little bit more, and it becomes a little bit more, until the point where I'm just dissolving the line and taking the soda machines and turning them into pizza machines, and taking the soda people who have been working on soda for 20 years, and I'm going to turn them into pizza people. I'm giving up a lot of soda at that point for just a little bit of pizza. This marginal cost increase, the more and more of a good that we're producing. The more and more pizza I have, the higher and higher the opportunity cost of that pizza becomes. So we want to use our resources efficiently. So as we move along, we have to consider what is this opportunity cost, and we have to stop when the opportunity cost gets too expensive. Dissolving the soda machines and never having a soda again, that's pretty expensive, right? Maybe instead we'll be happier here. Right here, we have about 2.5 million pizzas. We have the people who were working on pizzas previously, and now they're on soda. Like, we tell them to go back to the pizza factory. They're real happy. They have the knowledge there. We're taking the pizza ovens and putting them back in the pizza oven place. And notice that we're bowed outwards. In this case, we have 2.5 million pizzas. And we have about, I don't know, 10.5, 11 million sodas. That seems like a good amount, right? That's like 3 or 4 sodas to each pizza. People are pretty happy. Okay, all right, this could be good. Maybe that might be where we are to keep things efficient. So we have to kind of graph this marginal cost. Graphing the marginal cost will allow us to kind of figure out what this looks like over time, right? So it's just these little boxes that exist, the difference in between 1, 2, 3, 4, 5 million pizza and the amount of soda that you have to give up. And we're just going to push those all down to the bottom. So notice that this is when we went from 0 to 1 million pizzas, we gave up that 1 million sodas. Okay, when we went from 1 million pizzas to 2 million pizzas, we gave up 2 million sodas. Until the very end, where we go from 4 million pizzas to 5 million pizzas. And remember when we did that, we had to give up 5 million sodas. Well, this line right here, this is called our marginal cost line. It's how much we have to give up for each additional thing we're adding. All right? So, hold on one second. If you notice that there was a pause in the recording, it's because my cat was playing with a power cord and I really didn't want to lose this. All right, so we have the marginal cost. Now we know how much we have to give up for one more of something. How much do we gain for one more of something? Because I prefer pizza to soda, right? That's a preference. I'm going to get a benefit for each additional bit of soda that, or each additional bit of pizza that I'm getting, right? And I'm going to get more benefit for each additional pizza than I would each additional soda. And every person has their own preferences. Preferences are just the idea of what you like and what you dislike. Now, to describe preferences, we kind of use these concepts of marginal benefits. How much extra happiness do I get from one more of something? Let's imagine that you go down to the ice cream store, and let's also imagine that you like ice cream, because I know a lot of you don't, but you like ice cream now. So you're going down to the ice cream parlor. And that first scoop of ice cream on a hot day after it's been sunny and miserable, like, you're going to get a lot of benefit out of that first scoop of ice cream, right? And you're like, ah, this is delicious, yay. And then they give you a second scoop of ice cream. Now that second scoop of ice cream will increase your happiness, but will it increase your happiness as much as getting that first scoop did? How about I keep piling them on, and I keep piling them on, I keep piling them on, and I give you your 10th scoop of ice cream. At this point, you're like, I am so miserable. Please do not hand me any more. Please stop handing me ice cream. It's just going to melt in my car. Please stop. The extra little bit of benefit I get from that 10th scoop of ice cream, going from 9 to 10, I don't get very much happiness from that. Nowhere near what I would get from going from 0 to 1 scoop of ice cream. So the marginal benefit is how much extra happiness or how much extra utility, because we call it utility in economics, are you getting from one more? So let's just talk about the in general. The more we have of a good, the smaller the marginal benefit. Like if I go from 9 to 10 ice cream scoops, meh. If I go from 0 to 1, I'm like, yeah, but 9 to 10, eh. If I get my first pen, I'm happy, right? Because then I can take notes and I'm really happy. If we go from 99 to 100 pens, I do not care if I have a 100th pen. Where am I going to put all these pens, right? So the more we have of a good, the smaller and smaller the marginal benefit is, the extra little bit of happiness that you get from one more. And at the same time, the less we're going to be willing to pay for it. That first scoop of ice cream, yeah, awesome. I'd pay like $5 for this scoop of ice cream, right? Because like it's hot, it's miserable. I've been out working in the garden. First scoop of ice cream, like I'd pay for that. The 10th scoop of ice cream, I don't want. It's leaking in my car. I'm not happy. I'm not going to pay as much for that, right? My willingness to pay goes down. We call this general principle the principle of decreasing marginal benefit. The more and more you have of something, the less and less you're willing to pay for more of it. If I already have 99 pins, I'm not spending money on a 100 pin, but I will spend money on my first pin, right? So the marginal benefit curve, so we already showed you the marginal cost curve, which was increasing. The marginal benefit also has their own curve that I'm going to show you. And this is the relationship in between the amount of a good that I have and kind of what my willingness to pay for it's going to be. So let's go through this. Let's go through this at different points. At point A, we have 500,000 pizzas. Okay. Well, that's in a situation where I have a ton of pizza, right? I have pizza just growing everywhere. Or no, excuse me, sodas. I have sodas just everywhere, right? Let's say that I still live in Atlanta and the soda factory is there and there's just like 15 million sodas, but I'm hungry. So for that first 500,000 pizza, I might be like, oh, yeah, there's pizza now? I don't have to live off soda? That's great. Okay, all right, here, give me a pizza. I'll give you 5 cans of soda for this pizza. Okay, so my willingness to pay for those first additional pizzas, that's going to be like a lot. I'm willing to pay like 5 cans of soda for that pizza. Okay, all right, let's keep going. Now let's say that like I had those first couple pizzas, I'm happy. I'm still a little hungry, but like maybe not as much as before. Okay, well then someone offers me another 1,000,000 pizzas and I'll be like, I mean, this isn't as good as the first pizza, so I'm not going to give you 5 sodas for that because, like, I'm kind of full right now. But I'll give you 4 sodas per pizza now. Like, I still have a ton of soda. I'll give you 4 sodas per pizza. Okay, so my willingness to pay would be about 4 sodas per pizza at that point. And we keep going down, and we keep going down because by the time we get to, let's say, about 4 million pizzas, I'm definitely full. I really don't want much more. My soda stocks, they're just depleting, right? Because if we're at 4 million pizzas, remember we had that trade-off in between what we could actually produce. So like, I don't have a lot of soda left. So if someone keeps offering me pizza, if they want me to go to 4.5 million pizzas when I'm at 4 million pizzas, I might be like, oh man, I mean, I'll take these pizzas. But I'm not paying you the 5 sodas of pizza I paid for in the beginning. I'm paying you 1 soda. 1 soda each. Here's 1 soda for each pizza. Thank you. So this is kind of my willingness to pay. You see that the willingness to pay goes down the more and more pizzas we have. That's because the marginal benefit, the extra bit of happiness or utility I get for each additional pizza goes down the more and more that I have of it. So we call this decreasing marginal benefit from pizza. Okay? So we need to take this cost part and this benefits part, and we gotta smush them together. We gotta figure out where are our costs going to equal our benefit. Because notice on the graphs that I had shown you before, we have production efficiency. It's technically production efficient when I'm using all of my resources to make 15 million sodas. It's technically production efficient for me to use all of my resources and all of my people and all of my machines to make 5 million pizzas. But that doesn't mean that the store we're happy, right? Where we're happy is going to be where we're allocatively efficient. We're at a point where we have the things that we value. So maybe I value having 2.5 million pizzas about the same amount that I would like to have 10 million sodas. So like that's my happy medium. At that point, I can't really get much happier. I'm not going to be as happy with 5 million pizzas. I'm not going to be as happy with only 15 million sodas. Instead, I kind of want to be at like 2.5 million pizzas and like 10 or 11 million sodas happy. We call that point where we can't really give up anything without getting something less valuable to us. If we're at that like sweet spot, we call that being allocatively efficient. And that's the point that we prefer over all others. Actually, you know what? I'm going to stop right here, break this up into 2 different lectures so that you're not sitting down too much. Go ahead, stand up, stretch your legs, and get back to this when you're ready to get back to it. I'll talk to y'all soon. All right, bye-bye.